So this is a follow-up to the uh, video where we demonstrated how to convert these this data over here into a line, a graph, and the equation. We did it in three different ways, but the bottom line is that this data over here, again, the x's are the number of people trying to scalp tickets, and this is the price at which they're trying to scalp them. This would be data collected at some point over time at various events where people scalp tickets. So this then it was the formula that resulted. That was for tickets being scalped, and then this would be for tickets being purchased. Or people trying to buy tickets. Again, this is the demand. This isn't necessarily the actual transactions, but this is people trying to sell. So we see a lot of people, a lot of people trying to buy tickets when they're really cheap. And then when the tickets get really expensive, not so many people are willing to buy them. And this then is the data. It's more scattered. We talked about that and how the reality is kind of spread out, but this is our representation of reality here. And that line is also represented by this equation. So here we have reality. In other words, this describes the relationship between how many people want to buy tickets at the various prices. So now what do we do with that? Well, those formulas are not ready yet. The relationship here, what's the y? What's the part that's out here? Well, the part that's out here is the price, and the x that's buried in here, that's the quantity. So it's like this. And for our purposes, you will realize that that has to be reversed. So that's why we go to converting the formulas. So this should look familiar to you, y being the price. But then remember that in our demand curve, supply and demand curve, it's the quantity supplied and the quantity demanded that need to be out by themselves. Price is in the formula. So this is simply demonstrating the process of converting the formula. This is straight algebra. And if you're very clear on your algebra, then you don't need to follow through on these steps. But if you aren't, then obviously you're going to want to do this. So the first thing we do is we begin to use the variable letters that we use in price optimization. Y becomes P, and X becomes, in this case, quantity supplied, because this is from the ones that we're trying to scalp. So these are the suppliers, and this is the formula representing their willingness to supply at a given price. And all we do is walk through the process of subtracting basically the intercept from both sides, and then we end up with a situation where then both sides can be divided to get rid of this. And anyway, we end up with this over here and all of this that can be simplified down, and this becomes then our quantity supplied formula. We do a similar thing here with demand. Convert y to p, x to quantity demanded, and then do the math of conversion, subtracting, or in this case, notice this is a negative, so we can actually move this whole piece over and bring p over into the negative here, and it's a lot smoother perhaps than some of the others. Anyway, then that makes quantity demanded isolated by taking this factor and dividing it into the other two pieces. And then ultimately then we end up with a quantity demand formula where P is embedded in the formula and quantity demanded is by itself. So why? Well, then remember this. This should look familiar. Here we are with a price optimization, and if we double click on this, you will see that we take and embed price in the formula, and the result will be a quantity supplied based on the formula that is from the last sheet. Same thing with quantity demanded. Here's the intercept value, and then the negative 5.79 times A3. If you look back, you'll see that that was what the two were. And then we run our table. These prices we just came up with as we did in the past, creating a set of values that allows our quantity supplied and quantity demanded to intersect somewhere in the table. In this case, this is where they cross over each other. This one's less than this, and then this one is greater than this. So that's our intersect point, somewhere between $120 and $140. We created this chart to represent that, and sure enough, on the chart, you'll see that here's the point somewhere. If now price is on the bottom instead of up here, so somewhere between $100 and $150. So actually between $140 and $120. There, that's where our intersect is, and in fact, we'll realize soon that it's $135.06. But anyway, and then as far as the number of tickets sold gets to be around 700, and sure enough, it's there. So how do we get to these precise values? Well, I'm going to scroll down just a little bit and show you that we follow the price optimization process, where we take our quantity supplied formula and quantity demanded formula, and we match them up against each other and simplify down, and we will find then that the optimal price is $135.06. Then we feed that number into one of the other formulas, and you can use either one, and that gives us an optimal quantity of 726. So this is standard price optimization that you will do a lot of these kinds of things in economics, but I think this is helpful to understand how, at least one way, that we can get to that point from the raw data that we started with. We started with this kind of data, and we ended up with a supply and demand curve. Hopefully this is very helpful to you in your future.